Hello, everyone. Now, welcome back. In this lesson, we're diving into descriptive statistics. Now, descriptive statistics is all about summarizing and interpreting data in a meaningful way. Now, when we collect data, it can be quite overwhelming. We look at a massive list of numbers, and believe me, this is what scares a lot of my students. This is where descriptive statistics comes in, though. It helps us to make sense of data by identifying important trends or patterns or variations. And now in this lesson, we'll cover these three topics: the measures of central tendency, which includes finding the middle or most common values in data; the measures of dispersion, which is understanding how spread out the data is; and then visual representations of data, which is using histograms and box plots to better understand patterns. Now, by the end of this lesson, you'll be able to calculate and interpret key statistics and visualize data effectively. Okay, let's get started. First, let's talk about measures of central tendency, which tells us where the center of the data is. We're talking about the center of data here. There are three common ways to measure what the center actually is, and this is by identifying the mean, the median, and mode. Now let's break each one of these down by examples. Now, the mean is what most people think of when they hear the word average. You've probably heard on average many times. On average, how many times do you fall asleep in class? Or on average, how much caffeine do you consume per week? Now, to calculate it, we will simply add up all the values and divide the number by the number of values there are. So as an example, imagine 5 patients' heart rates were 70, 75, 80, 85, and 90. To find the mean, you would go 70 plus 75 plus 80 plus 85 plus 90 divided by 5, since there are 5 different sets of values there. That equals 80 beats per minute. Now, the mean is useful, but it cannot be affected by extreme values or outliers. As an example, if one patient had a heart rate of 200, it would drastically increase the average, as you can imagine, which is less representative of the whole group. Now, next we have the median, which can help us understand the data, which is the middle value when data is arranged in order. So using the same 5 heart rate values, we have 70, 75, 80, 85, and 90. The median is 80 because it's the middle number. It's in the middle. If we had an even number of values, then we'd take the average of the two middle values. The median is especially useful when data has outliers because it's not affected by extreme values. You can see why it's useful now. Now, finally, the mode is simply the number that happens most frequently in the data set. As an example, in the set 70, 75, 80, 80, and 90, the mode is 80 because it appears twice. Now, if no number repeats, there is no mode. If multiple numbers appear within the same highest frequency, then we can have more than one mode. So if there was like 2 75s here and 2 80s, there could be 2 modes, 75 and 80. Now that we know how to find the center of a datasheet, let's talk about measures of dispersion. This tells us how spread out the data is. Now imagine 2 classrooms taking the same test. If one class has scores that are very close together, and another class has widely varying scores, we need a way to measure that difference. That is where the range, the variance, and the standard deviation come in. Here's a measure of dispersion graph using simple data. It visualizes the data points along the mean and includes key statistics like range, variance, and standard deviation. Now we will get more into this. Okay, so the simplest way to measure spread is the range. Just subtract the lowest value from the highest value. For example, if test scores range from 50 to 95, the range is 45 because it's 95 minus 50. But range alone does not tell us how the values are distributed. It really only gives us a rough idea of the spread. So here's a visual to show you this. This is a histogram, which I will cover more in detail shortly. But just using this as a visual aid, you can see the range is 10 of these units. You can see right here, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are known as bins, by the way. They're user-defined categories or ranges that are created for grouping data points. Now, to get a better picture of spread, we use variance. Variance measures how far each value in a dataset is from the mean. So a high variance means the data points are spread out, while a low variance means that they are close together. Now, what this graph shows is that the data is spread across the range of 50 to 95. And as you can see here, we have 50 and 95 up here. And it has fairly even frequencies across these bins. Now, there's no single peak. It's relatively flat and balanced across the histogram. The mean is 73.96, and the mean is right here. So this is the middle. You can see the number, the mean number up here. It's shown by this red dashed line. Now, since the values are spread across the full range, 50 to 95, and not tightly clustered around the mean, the variance is likely to be high. Variance measures the average squared deviation from the mean, and because the values are consistently distant from the mean on both sides, it increases the variance. The fact that several bins near the edges, like 50 to 60 here, and 85 to 95, have solid frequencies. This means that many values are far from the mean, which boosts the variance. Here you see frequency. This boosts variance. Now on this graph, higher variance is reflected in how spread out the data points are from the mean, which is this red dashed line here. Here's what indicates that. Most of the data is clustered between 10 and 20, as you can see here, but there's a data point at 30 up here. That outlier, 30, pulls the mean upward and increases the spread of the data. Because the values aren't tightly packed around the mean, the variance and standard deviation are higher. If all the points were closer to the mean, say 13 to 17, variance would be lower. That single high value, 30, is doing a lot of the damage here. Classic example. This is a very classic example of how outliers increase variance. Now, the standard deviation, or SD, tells us the typical distance of data points from the mean, which really means that the exact mean value in this data set here is 73.96. So it's approximately 74. It's simply a square root of the variance. So the standard deviation is the square root of the variance. This brings the measurement back to the original units. Now, the standard deviation on this graph is 4.93, which means that on average, each data point lies about 4.93 units away from the mean. So it gives us a sense of how consistent or variable the data is. Even though standard deviation isn't directly drawn as a visual line like the mean is, you can feel its presence just by noticing how far many of the points are from the red dashed line, this line here. And this heavily influences the standard deviation by pulling the average spread wider. A lot of points are relatively close to the mean, say 13 to 17 in this area, but that one outlier stretches the average deviation upward, this one here. So a low standard deviation would suggest most values are tightly packed around the mean, and a high standard deviation, as I'm showing you here, means there's more variability and results are less consistent. Now, possibly without you even knowing it, I described to you data in a visual representation, found in the previous slides, to illustrate this point that these visual representations are extremely helpful. And the two most common ways to visualize data spread are through histograms, which we just observed, and box plots, which we will look at soon. Now again, a histogram, or a frequency distribution, looks like a bar chart, but groups numerical data into ranges or bins, as I mentioned, these little bins here. A histogram arranges numerical data into ranges or bins instead of categories. So as an example, if we measure ages of patients in a hospital, instead of listing every individual age, we can group them into bins like 1 through 10, 11 through 20, 21 through 30, etc., and count how many fall into each bin. Now, box plots are great for showing the spread of data and identifying outliers. The box represents the middle 50% of the data. The line inside the box is the median, as you can see here. The whiskers are these parts here, and this one here, and show variability or outside the middle 50%. And the dots outside the whiskers, these ones here, indicate outliers. Okay, so here's another box plot. It has a red dashed line again representing the mean of this data set. Here's what each element in the image tells us. The box itself is a quartile range, or known as IQR, which is the spread of the middle 50% of the data. So this here, this box here. So this is represented by the length of the box itself and is calculated as the difference between the third quartile, which is known as Q3, and the first quartile, Q1. This represents the middle 50% of the data set. So it shows us where most values are concentrated. The black line inside the box represents the median, this one here, or the middle value of the data. Now the whiskers again, these are the whiskers on each side, extend to the lowest and highest values within the range of 50 and 95. As you can see down here, you have the 50 and then 95 up here. Now the red dashed line is the mean. Again, the mean, the average, is now clearly marked to show you how it compares to the median, which is the black line. So the mean is the dotted red line, the median is the black line. If the mean and median are close together, the data is symmetrical. If they are far apart, however, the data may be skewed. This visualization makes it easy to discuss the relationship between mean and median and how data is distributed. Okay, you got this. Way to go. So now in this video, we discussed measures of central tendency, the mean, median, and mode. We also discussed the measures of dispersion, which is the range, the variance, and standard deviation. We also covered the visual representations of data with a histogram and box plot and learned about each in detail. Well done. Look at how well you are doing. Now I will see you in the next video.